Example, categorical frequency distribution number 1. A teacher records the responses of the class, 28 students, on the first question of a multiple choice quiz with 5 possible responses, A, B, C, D, and E, in the table below. Create a categorical frequency distribution that organizes the responses. Now in this table, because there are 5 possible responses, what we are doing is organizing the frequency of each of these categories. So if we read through this table and we look at the information we have, there are 5 categories. We have category A, which I'm going to be writing in a table here that is with the header column or header row is titled category and then frequency. So the first category is A, the second category is B, the third is C, fourth is D, and fifth is E. And so all that remains for us is to count the number of each category. So if we count the number of A's that appear, that is a frequency of 14. The frequency of B is 4. The frequency of C is 6. Frequency of D is 0. And the frequency of E is 4. Now a good choice is to go ahead and add up the frequencies that you have. So in this case 14 plus 4 plus 6 plus 0 plus 4, and guarantee that that is the total number of pieces of data you have. There are 28 students, the frequencies add up to 28, and so this is complete. Example, categorical frequency distribution number 2. Attendees of a conflict resolution workshop are asked how many siblings they have. The responses are in the table below. Create a categorical frequency distribution that organizes the responses. So as we look at this table, we see that there are a number of responses ranging from 0 up to 5. And so we will make a table with a first column of category and a second category of frequency. And the first category is 0, the next is 1, then 2, then 3, then 4, and then 5. Now if we count how many zeros, how many no sibling instances occur, there are 5 zeros in our table of data. Category 1 has 13 in it. Category 2 has 6. Category 3 has 3. Category 4 has a frequency of 2. And Category 5 has a frequency of 1. Now if we add these frequencies up, so 5 plus 13 plus 6 plus 3 plus 2 plus 1, we should get a total of 30, and this table of data is a 3 by 10, 3 rows, 10 columns, so that should match. And it does. Example, bend frequency distribution. Use the given data to construct a frequency distribution. On a math test, the scores of 16 students were 99, 73, 72, 66, 72, 72, 99, 85, 73, 82, 72, 73, 82, 72, 73, and 85. Use 4 classes beginning with a lower class limit of 60 with a class width of 10. Because this is a bend frequency distribution, we are going to use ranges, okay, also called classes, where we have a lower class limit of 60, and our first bin has an upper class limit of 69. Because the class width of 10 means the difference between lower class limits is 10. So our first bin in our table is 60 to 69. The next is 70 to 79. The next bin would be 80 to 89, because again we are adding 10 to the lower class limits. And then finally 90 to 99. And so we need to count the number of pieces of data between the numbers 60 and 69. And as we look through these very carefully, we have one item that's between 60 and 69, so that bin has a frequency of 1. We have 9 pieces of data between 70 and 79, so that the second bin has a frequency of 9. Next, we have 4 pieces of data between 80 and 89, so that the bin 80 to 89 has a frequency of 4. And finally, we have 2 pieces of data between 90 and 99, so that the bin 90 to 99 has a frequency of 2.